So let's take another example. Integrate this. Okay. Now this is again of the form which I had discussed. What I'll do is I'll try to write x plus 1 as lambda times derivative of 1 minus x square plus some constant mu. This is equal to lambda times minus 2x minus 1 plus mu. If you compare the coefficients of x and the constant, you will get lambda as minus half and mu as half. Okay, so my equation becomes integration of minus half minus 1 minus 2x plus half into 1 minus x square dx. Okay. Now this I can write it as minus half integration of minus 1 minus 2x into root of 1 minus x square dx plus integration of half into 1 minus x square dx. Okay. Now this one, if I take this as t, this becomes dt. So it's simple integration of root t dt. Okay, and here I have half into integration of root 5 by 2 whole square minus x plus half whole square dx. So this is of the form of a square minus x square. This becomes what? This becomes half into t to the power 3 by 2 to 3 by 2. Okay, and this becomes half of half I have used the formula of integration of a square minus x square dx. Plus a constant. So this becomes my final answer. I have replaced t with this value. This is my t. This becomes 2x plus 1 by 8 to 1 minus x square root under plus 5 by 8 into 2 16 sin inverse 2x plus 1 by root 5 plus a constant c. So this is my final answer. Okay. Now let's say you have an equation of this form. The form of the equation is a square plus bx plus c divided by px square plus qx plus r dx. You have equation of either this form or this form or of, let's say, this form. Now if you have equations of this form, then what do you do? In that case, what you need to do is that, first of all, try to write ax square plus bx plus c in terms of lambda times px square plus qx plus r plus mu times derivative of px square plus qx plus r plus a constant gamma. Now why we write this in this way is because, okay, after you write that in this way, then try to compare the coefficients and try to find out the value of lambda, mu and gamma. After you do that, you will see that this equations, this whole integral can be segregated into three parts, and when you write this in this form, you will have this one divided by this one, which becomes only lambda. Here you will have something in the denominator and a derivative on the numerator, so this will turn out to be in the form of dt by t or dt by root t, and you have a constant divided by a 2-degree equation, which can be simplified, and you can use some standard equation. It will become more clear when we take an example. So let's take an example. Let's say you are asked to integrate 2x square plus 5x plus 4 divided by root under x square plus x plus 1 dx. Now in this case, as I told, try to write the numerator in terms of lambda times the polynomial in the denominator plus mu times the derivative of this. Derivative of x square plus x plus 1 is 2x plus 1 plus a constant gamma. Now let's compare the coefficients. 2 equals to lambda, if I compare x square. 5 equals to lambda plus 2 mu. From here you will get mu as what would be mu? Be 3 by 2, and 4 equals to lambda plus mu plus gamma. So your gamma turns out to be half. Okay. So now your lambda is 2, mu is 3 by 2, and gamma is half. Okay. So now you can write the integration in this form 2 times, because I can write this, I can replace this with lambda times this plus derivative of mu times derivative of this plus gamma. So I can write the numerator as 2 times x square x plus 1 plus 3 by 2 times 2x plus 1 plus half divided by x square plus x plus 1 dx. So now this becomes 1 plus 3 by 2 times 2x plus 1 by this expression plus half times by this expression dx. This one now you can write it as root of whole square. This one will be 3 by 2 t to the power, sorry, you have dt by root t, because if you take this as t, it will be dt plus half of this expression, you can write it as plus 1 by 2 whole square plus root 3 by 2 whole square. Now this can be solved using some standard equation. This is a very simple integration, and this also has a standard result. So you see that using the approach we had mentioned, you are able to convert this into 3 standard integrals. So you will be able to solve the question. Okay. So I won't be proceeding further in this question. We will move on to the next question.